All right, welcome everybody. This is the post VMworld vBrownbag. So tonight, September 9th of 2015, we are doing administrating and managing vSphere 6 resources with Manny. He's at Manny. I'm sorry, I don't want to butcher your last name. Can you say that for me?
VF Sidhu, SIDHU Sidhu, so H is silent, yeah.
All right, thanks. So some just quick show notes. You can join in on the conversation using the vBrownbag hashtag on Twitter. You can also enter in questions in the GoToMeeting window. And we also have other shows going on globally, so check those out. Tonight we have Manny talking. I'm your host, Ahmad Yunus, and I'm going to pass it on to Manny.
Now you gotta tell me how I can move how I can use my second screen for this.
So here's what's going to happen. I'm going to change presenters to you.
Mm-hmm. Mm-hmm.
If I can find you in the list.
No worries.
You are not on the list. There we go. So now
Okay.
you should be able to.
If I'm waiting for that screen which says, change screens. So just one sec. All right. Can you see a PowerPoint?
Yes, we can.
Presentation. Okay, great. So, all right. Let's get started. So you might already introduce me, so I don't need to say much. So that's my name. I'm from Melbourne, Australia. It's my Twitter handle, and I blog at virtual10.com. I usually blog about Log Insight and VROPS these days. So today, as you might have said, we're going to be talking about section 5 of the VCP6-DCV blueprint, and we will talk about resource pools and vFlash. So in resource pools, we'll talk about the hierarchy. We'll see how we can create, configure, edit resource pools. We'll see how we can create reservations, shares, and limits, and how they, work together in a cluster, for example. And we break it up into these two sections, although the blueprint is a little bit different, but I think this is how it'll flow better. And we'll talk about vFlash in the next section, so which is now called, vFRC. That's a whole, big abbreviation. So vSphere Flash Read Cache, and I think it used to be called vFlash, and that's what it's called now. We'll see about how we can create a vFRC pool, and we'll see how we can assign the cache to VMs, and we'll also look at how we can use ESX CLI to take a look at what's going on. Got a few URLs from the blueprint, so the resource management guide, the VM administration guide, and a what's new in the Flash Read Cache. So to me, if you guys go through these three guides or these two guides and this article here, you should be pretty set for this section for the VCP exam. So I put together a list of notable tips, which I usually talk about or recommend. So first one is you must use resource pools with care, or maybe not use them at all, because they may require frequent tuning. We'll talk about why in a bit. And please don't use them as folders. I've seen people use that, and it is not a good idea. I'll talk about that too. And we'll talk about reservations. So use them sparingly, if at all, because this affects your consolidation ratios, because that's what virtualization is all about. So make sure you use them carefully. And shares, they only kick in, when times are tough and there's, like a drought-like condition. So that's when shares kick in, only when there's contention, not otherwise. And reservations will always trump shares. As for limits, I don't see why you would use them. I don't even know why VMware have it in there. From memory, I think Scott Lowe used to talk about limits and say, if you want to drain a host of VMs of the resources that VMs use, you may use a limit, but yeah, you just tell people that something's going to happen, and you just shut VMs down. You don't use limits at all. So please don't use limits. If you find yourself using limits, you're doing it wrong. As for vFlash read cache, I may pronounce this abbreviation, wrongly during this, as it's a whole big word, but I think it never really took off. And if you think about vSAN, it's just completely, destroyed it. And I don't think, vFRC, no one ever used it. And it does read acceleration only, so that's the write-through mode. It doesn't do any striping or copying of data. So if if a VM exists on one host on which its cache exists too, but the cache doesn't exist on the second host, when you vMotion it to a second host, the cache will get copied too, and for the cache to warm up, it'll take a while, and during that time, the VM's read performance will suffer to some extent. And you can use up to 400 gig of cache, and it needs to be enabled across hosts for DRS or vMotion to work. And just so you know, HA will attempt to restart VMs on host with VFRC enabled. Got a couple more slides, and these are default share values. I'll talk about them during the presentation, but there's a quick view about the shares and the share values, where they come from. All right, so I'll go to my lab here.
Manny,
just in case anyone's wondering.
Question?
Yep.
So looks like 400 gig per host or per guest?
Now 400 gig per host. Yes, per host.
Thanks.
Yeah, you got me thinking there. I think that's per VM, I think. Sorry, I'm not sure. We've got to figure that out. So going back to my lab, in case someone's wondering, so I've got 3 virtual ESXi hosts. They're all run 6 right now, and we've got 4 VMs inside running in that cluster. So yeah, so resource pools. So what are they? So resource pools are basically, like just what they say. So pool of resources. So they could be CPU, it could be RAM, or storage, and they span clusters. So that's a given too. So by default, everyone has at least one resource pool. That's your host, and most people will have clusters, so you'll have at least 2 resource pools by default. Just quickly do a whiteboard here. So this is a pretty handy whiteboard website. So we might talk about this thing called resource providers and resource consumers. Basically, resource providers are the clusters themselves and the parent resource pool, which can be the cluster, or if you're multiple resource pools, then the one above is a parent resource pool or the resource provider, and anything under it is a resource consumer. So just to quickly whiteboard it, so got to bear with this. So I'm going to draw with my mouse here. So let's say that's your cluster. The words are going to be a bit funny, so please bear with me. So let's say that's a resource pool 1, that's a resource pool 2. So like I said, so the cluster is the provider, so that's your resource provider. So these 2 babies here, they'll be the resource consumers. But for anything under it, these are also resource pools, so resource providers, sorry. And similarly, if you have more resource pools sitting under here, these are also resource providers as well as resource consumers. And any VMs under here are, let's say VM1 and 2, they are resource consumers. So you may get asked a question like this in your VCP exam. May. So refresh this. We have a fresh whiteboard for the next one. Minimize that in the meantime. So for resource pools to work, you need DRS enabled, right? So at the moment, if I check my cluster here, of course DRS is turned on, and sure enough, I can go to the root of my cluster and create a new resource pool. So that's lit up, and it lets you choose the various options. If I were to disable DRS, you will see that I can't create a resource pool anymore. So for resource pool to be created, you need DRS enabled. We turn it back on because we are talking about resource pools, so we better have them on. So the most handy tab in this in the resource pool discussion is the resource allocation tab right here. So by default, as you can see, every VM has no reservations. So memory or CPU or storage, and the shares are normal. So everything is going to be normal for now. It's because there are 4 VMs inside of here, so that's why the shares are 25% each. So for the 5th VM, the shares would have been 25 each, and 20% each, and it was for 6 VMs it would have been about 16% each. That's how the cluster divides its resources up. And once again, shares only apply during times of contention. So this is quite important for your VCP exam, and in the real world too. Shares only kick in when there's contention. Reservations, on the other hand, will always trump shares, and they always apply when the VM's powered on. They only apply when the VM's powered on. So yeah. So once again, so the the part that you see up here. So that's the total that's available to the VMs. So that's about 7.5 gig, and that's the total memory. So let's go about creating a resource pool to begin with. So let's call this like a production.
We have a quick question. For DRS, do you need enterprise or is essentials okay?
No, I think you need enterprise for this. Yes. All right, so we go ahead and create a production resource pool. So just before I actually do this, so just see what the number of shares are. So at the moment, there's 25% shares each per VM. The moment I create a resource pool, you'll see the number of shares drop. This is one of the reasons why you shouldn't use resource pools as folders. So even without doing anything after this, you will see that the number of shares per VM actually drops. So I'm leaving this as everything as a default. I'll talk about how these numbers came about, but for now, we just go OK here. And sure enough, the number of shares or the percentage of shares per VM actually dropped from 25% to down to 12%. So once again, so the resource allocation tab is where you go and do your thing here. As for using a resource pool as folders, we'll go off on a quick tangent and just say that if you want to be actually using folders, if you want to create folders for your VMs, you're actually better off creating them inside your VMs and templates view. So you just create your folders in here, just go new folder and do your thing here. Do not use them as folders at all. So just for argument's sake, so if I were to create another resource, we'll just call it RP1. It doesn't matter what level of shares they have, just for something different, and you'll see that the number of resources will actually drop even further. Hence why you shouldn't use them as folders. So within a resource pool, let's talk about what's contained in a resource pool, what you can set in a resource pool. So the name can be changed at any time. Doesn't matter. There's no outage. No one ever notices. So by default, every resource pool is going to have a normal CPU shares and normal memory shares. You may wonder where these values came from. I used to wonder that too, and I actually discovered this a few days ago, and it actually comes from. So it considers every resource pool as a 4 vCPU VM and having 16 gig of RAM. If I go back to my presentation here, my PowerPoint thingo. So that's where it comes from. Normal, it considers itself a normal VM. So by default, it's going to have 4,000 shares of CPU and that many shares of RAM. Also, guys, the actual number doesn't matter. What matters is the ratio. It's actually the ratio that matters. It's not the number. And just once again, it doesn't matter what the share setting is. What matters is the actual number. We'll talk about now we talk about all the various settings that you can set inside the resource pool. So once again, so low, let's you have 2,000 shares, normal 4,000, high, and you can custom. You can tune your resource pool to whatever you need. It's actually a good idea to do this. So you shouldn't be leaving them as the defaults. I will recommend that you tune your resource pools accordingly as needed. And the CPU reservation, for example, it'll go up to the maximum available. So that's the entire cluster. That's how up you can go. The expandable reservation, what that means is if I go back to I should have kept my previous one. So let's say I've got this resource pool up here, and we call it resource pool 1. And it's got baby resource pools inside it, so 2 and 3. Jeez, my handwriting's terrible. I actually write better in real life. So what expanded reservation means is that if a VM under here is requesting more memory than the resource pool that actually got, if the expandable reservation checkbox is checked, it'll actually go up to its parent and ask for resources to be given to it. Once the VM's finished with it, it'll probably flow back to the parent resource pool, and it's done with it. So that's what the expandable reservation checkbox is about. So it can ask the parent for more resources if it can't satisfy the reservations that a VM's requesting. The limit, like I said, you shouldn't use limits at all, and it's grayed out by default because the unlimited checkbox is checked. So by default, obviously that's checked, and a VM or any VMs inside of it can request up to that much. So that's the total that the cluster's got. If you uncheck that, you can tune it. And like I said before, you shouldn't be using limits at all. So it's best to leave this at unlimited. If you do use limits, you'll find yourself doing it on every VM, and it just becomes a nightmare. Same thing for memory resources. So normal by default, that many shares by default, and the reservations is 0 meg to start with, and can go up to as much as the cluster allows. So that's 13, 13 gig. Once again, the expanded reservation does the same thing, and so does unlimited. And once again, so reservations will always trump shares at all times, and shares only work during times of contention. And I was talking about how you shouldn't use resource pool as folders, and we'll also talk about how placing VMs at the same level as a resource pool is not a good idea. So as you can see, 50% shares are reserved for the production resource pool, and 12% each for each of the VMs. So you may find that if you put your VMs at the same level of hierarchy as the production resource pool, in some conditions, the VMs will actually end up having more resources than the resource pool themselves. So that's why it's not a good idea to have them sitting at the same level as your resource pools. And they talk about the sibling rivalry in shares. So if let's say if I want to get rid of the production resource pool, so every VM is now at the same level, and they are competing against each other. That's what shares are about. And so, the shares only work with siblings. So if a VM is sitting if there's two VMs sitting in a different resource pool, and the other two in like a second resource pool, they're not siblings. So the resource pool are siblings of each other, and they compete against each other. So once again, shares are for siblings only. And again, it doesn't matter what the setting is. What matters is the share value. We go and create the resource pool again. I should have probably left it in here. Can't type correctly today. So what we might do is just to show that how sometimes resource pools work is, so we left the share values at normal. So let's go and drop a VM into the production resource pool. So now it's sitting inside of it. So if I look at the resource pool itself, you'll see that it is permitted to consume 100% of the shares that are available to the resource pool itself. So let's say, just for argument's sake, let's go in and set the shares at too low. So I just go custom here. You just go 2. It's going to be very low. That's okay. So we go in and drop VM13 into the resource pool, and that warning is going to show up. That's what I wanted to talk about. And something like this would also be good material for the VCP exam. So what I'm trying to do here is I'm trying to drop a VM which has very low shares configured on it, or very little share configured on it. And if I were to drop it in, the VM is going to be entitled to 0%. It's not actually 0%, but it's so low that it's actually almost 0%. So do you want to continue? I'll just say yes for now. And if I go into memory, you'll see that VM10 is going to, just kill VM13 when there's contention. And that's actually not 0. It's actually 0.1111 or whatever. But just for simplicity, they put it at 0 here. So let's talk about.
We have a question.
Yeah, go on, Mike.
So why not create resource pools at the bottom and have no VMs on the root? Let's see. That would be best practice, or do you have other suggestions?
Yep, that would be an idea. But once again, so you'll be frequently tuning your resource pools, and I'll show you why that may not be a good idea. So I'll create a like a development resource pool here. Just go, low here and go, okay. We drop VM 1 and 12 in here. So while this happens, so Duncan Epping and Frank Denneman used to talk about this, or they have talked about this thing called the resource pi paradox. We'll talk about that right now. So go and create a new whiteboard that'll answer this question. So what happens is, let's say there's two resource pools, just like the asker just asked. So if I can draw a circle. So let's say this is the development pool that I talked about. Let's go test here. Let's say this is prod, and so prod has, let's say it's got, just for argument's sake, it's got 1,000 shares, 1,000 memory shares or CPU shares, it doesn't matter. And for the test resource pool, let's say it's got 400 memory shares. So what's going to happen is, as you go on creating your VMs, you may find yourself in situations where, let's say you drop a couple of VMs into this resource. So it's divided up into two now. So both the VMs will have 500 shares by default. You do the same thing here. So you drop two VMs, and two VMs have 200 resource pool, 200 shares each. So as word spread that you as a VMware administrator has actually created resource pools where one resource pool has a lot of resources, and everyone's going to be clamoring to have the VMs put into this resource pool. So as time goes on, you go into pressure, and you start plunking every VM into this. So maybe not every, but say you've put in 4 VMs into this, and you are creating every other VM into this resource pool. So what's going to happen is these 4 VMs will have 100 shares each, right? But in this case, so you're putting in every VM into this. So you're dividing up the bigger pie into smaller chunks or smaller slices. So as you keep on dividing, the lines are pretty crooked, I know. So as you keep dividing, let's say you put in, let's say 20 VMs inside of this. So by default, although this is a bigger pie, or it should have had a bigger slice of resources, every VM is now going to end up having just 20, for example, just for argument's sake, just 20 shares each. So when there's contention, and the contention could be pretty severe, your VMs inside of this could probably be, bawling their lungs out, asking for more resources. But the ones here, which should have had less resources, are actually much happier at 100 shares. So that's what happened. This is what they call the resource pi paradox. That's contained in Frank's and Duncan's book. So that's pretty good. So to me, it's just best to leave your VMs sitting at the root of the cluster instead of creating resource pools. So first thing, so you'll be constantly tuning your resource pools to suit the number of VMs that are inside it. So if you put in more VMs, you say, I want more resources. Let's tune it again. Let's keep doing it. So it just becomes a nightmare at the end of it. So I'd prefer to put every VM at the root of the cluster. I hope that answers the question.
Yeah, we actually have even more questions. Is having a
Let's do it.
a share percent of 0 a bad thing?
Sorry, I heard a bell go off, so I didn't hear you properly.
I'm sorry. Is having a percent share of 0% a bad thing?
Percent share of 0. I don't know why do you do that? Yeah. So percent 0 would mean that the VM has no resources at all. So
he's talking about he's talking about where you set it up for 2 shares as an example, when you had it for 0% and then 99%. That's what he was trying to figure out.
Oh, okay, yeah, gotcha. Yeah, so that's not going to work. So like I said, during times of contention, it's not going to be a good idea, and I wouldn't do a 0%. No, I wouldn't.
Okay, and so use resource pools if you are a micromanager and want to granular control and love clicking. Leading, you can control resource pools via PowerShell as well.
You could definitely do that, yes. I actually looked up a pretty cool PowerShell script by Chris Wall. He's got this pretty nifty PowerShell script that creates and tunes your resource pools. Yeah, you can definitely do that using PowerShell. Yeah.
Okay, that's all the questions as of right now.
That's fantastic. So we've talked about the resource pool paradox. That's a pretty good question. Thanks, guys. Thanks for asking this. Now, while we are here, we might just talk about the resource pool depth. So VMware recommend that the maximum recommended value is 4. So when I did the the depth of the resource pool. So you probably go, 1 here and 2 here, and you maybe have 3 here. So they go that 4 is the maximum depth you should go to. That's a recommended depth. You can actually go down to 8. If you would do that, that's a terrible idea. It's going to be a logistical, nightmare, or administrative nightmare. Sorry. That's what it's going to be. My recommendation is to have just 1, or maybe not have them at all. What I would do is if absolutely needed, is probably create a resource pool just for my management VMs. For example, my vCenter server, the database server that hosts the vCenter database, maybe VUM, and maybe a domain controller, or maybe VROPS if you use that. All your management stuff. If you would like to have a resource pool, but personally, I don't like resource pool at all. But people do use them. Well, just don't use them as folders, please. That's just wrong. Let's quickly talk about the setting of the reservations at the VMs themselves or at the resource pool. What's a better idea? So if you were to create a resource pool, it's actually a better idea than creating reservations on the VMs themselves. That's because the reservations that you set on VMs are static, and they don't flow back to the cluster for being handed out to other VMs. But if you use them in a resource pool, once the VM's finished with it, it'll flow back to the resource pool and be available to other VMs in the resource pool. So yeah, so it's better off. You're better off creating. If you find yourself creating lots of reservations, you're probably doing it wrong. And if you still need to, maybe create a resource pool, maybe. So whatever works for you, really. So one size does not fit all. As for creating static reservations on VMs, it'll affect your consolidation ratios, and it'll affect your admission control policy as well. So if you were to use a default admission control policy, which is the host failures one, so that uses slot sizes. So slot sizes are determined by the size of the largest VM. So let's say maybe you create a large VM, say 48 gig, and you actually reserve all of the RAM for that VM. You're actually creating a 48 gig slot. And let's say the host has 480 gig just for simplicity's sake. So you can only create 10 more VMs, and you possibly can't even create 10 more because there's a fair bit of overhead too, and the host needs some memory for its own use for the kernel itself. So it's not a good idea to have reservations on VMs. But they are guarantees of absolute, they're absolute guarantees of resources. So if you absolutely need to guarantee for VMs, guarantee resources for some of VMs, you may want to do that. So maybe if you have some heavy-hitting VMs, so let's say you've got SQL VMs or maybe Exchange or something like that, you might be better off having a different cluster for those hard-hitting or heavy-hitting VMs. Just keep in mind if you put in a new cluster, it'll actually increase the load on your vCenter because vCenter needs to do all its calculations every now and again. And the busier or the more clusters that you create, the busier the vCenter is, and more resources it needs. Also with resource pools, so let's say if a host were to die and it's down, and every VM is going to be restarted on the remaining or the surviving host in the cluster. So performance is going to suffer till you replace the VM. Maybe it could suffer till if there's contention, and it'll continue to happen till you replace that file host. Also, let's go back and talk about the reservations on the actual VMs themselves. So you maybe ask questions on this here. So by default, so this is how you create reservations or tune your share values on specific VMs themselves. So again, so normal 1,000 shares of CPU reservation, it can go up to as much as is permitted by or is available to the entire cluster. It's the same thing for memory, and you may see that this orange triangle here. So that's a limit so that's a configured memory on the VM. So you obviously can't reserve more than it's actually available to the VM. Obviously, we won't go okay to that, but yeah, so that's what it is. Also, once you create a reservation, the vSwap file that is created per VM, that goes away because then the host knows, or the kernel knows that this particular VM needs an absolute guarantee of resources. So it's going to guarantee that a certain amount of physical memory or machine memory is available to the VM, and it won't create the swap file for you.
So we got a
What
few
next?
questions.
Okay.
Creating resource pools for storage LUNs, or is that a different topic?
That's probably a different topic, yeah.
Yep.
Yep.
Let's see. Is there existing? I'm not sure what the question is, but it just says, "Is existing storage DRS?" Troy, you want to elaborate a little bit on that?
Sorry, did you ask me or?
Well, the Troy was asking the question, so
I don't understand the question.
okay, he was associating it with the above question, which is a different topic. So we're good. I can see this in the chat.
Okay.
Okay, what we got right now?
Okay. Okay, cool. There's also this advanced CPU thing here, so I might just talk about that too. So we'll go and disable DRS, and you'll see that the resource pools just suddenly disappear. And yep, so if you choose to disable DRS, doing so will remove all the resource pools in cluster. So yeah, we go okay with that just for now. So that'll just drop all your VMs into the root of the cluster. So just once again we go back, not migrate. So we go edit settings here again, and resources. So this thing lights up. So what this thing is going to allow you to do is maybe allocate a particular core on the host to this particular VM. Now this may not be a very good idea because why? Because the first thing is that the vMotion will break, so you wouldn't be able to vMotion this VM to any other host. And you'll need a manual mode DRS cluster for this to work at all. Why this is not a good idea is because although this will pin this VM to this particular core, if there's any other core that are available for this VM to run on, the kernel will not schedule this VM on those cores, even if the cores are not doing much work. Although other VMs can use this core if it's available. So I just wanted to run this past everyone. So this is also a potential VCP question. I'll go back and enable the errors. Any more questions yet?
Let's see what we have. No, as of right now, yeah, we're good.
Okay. What else could I talk about in resource pools? I think that's about it really. So probably move on to the. Oh, maybe I just conclude with the about resource pools. So like I said before, it's best not to use them at all. So the manual effort is likely not worth it. And if you do see yourself setting reservations, just maybe set them on the VM themselves and not use the default HA admission control policy. Just go with percentage base. It's actually more relaxed, and you'll be able to build more VMs that way. And also, if you need to reserve resources on the VMs themselves, then reserve as much as the average expected guest RAM usage and not the peak. So peak's going to be obviously much higher, and average is probably the way to go. So if the VM needs more resources, it'll actually claim, it'll actually get the host to dish out more resources to it. So that just gave me an idea. I might just talk about how a host may reclaim memory and how it plays out with reservations and shares and all that stuff. So let's say this is a VM and it's got 8 gig of configured memory. So that is the configured memory, right? So you go in and create a reservation of, say, maybe, obviously that's not on the scale. So let's say this is 2 gig. So this 2 gig here, that's a static entitlement. So that's statically assigned to this VM. The kernel will never take it away. So let's say that is your static or your reservation. So as time goes on, the VM needs more resources, and the host just gives it out as till up to 8 gig. So like I said, as time goes on, the VM asks for more memory, and it goes up to say 6 gig. So this 6 gig here is comprised of the active memory and maybe some of the idling memory and some of the overhead. So when times are tough and the host needs to reclaim some memory or some resources or some memory in this case, so it'll ask the VM to inflate its balloon driver, and it'll start requesting the VM to hand back the VM that it was given, the resource that it was given. So the host will actually be able to reclaim up to the 2 gig. So at all times the host will let the VM have at least 2 gig of RAM available at all times, provided you set the reservation. So a reservation of 2 gig of RAM will never be reclaimed by the host, ever, even in times of contention. Yep, I think that's pretty much it. That's all I want to talk about resource pool. We could probably go on for this forever, but in the interest of saving some time, we'll go on to the next section. Yep. So once again, we'll talk about the flash read cache and why it never really took off and everything else here. So we'll log into my lab here. So the vFlash read cache was actually introduced in 5.5. I think it was called something else before. I don't recall the name of it, but this particular thing was introduced in 5.5. So this is per host. It's not at the cluster level. You can't create a data store. You can't create a VFRC data store. It's at the per host level. The best thing about it is that you don't need to modify the OS or any application that run inside the guest VMs themselves. So this thing is absolutely transparent to applications. And just once again, it operates in the read. It just serves out read IOs. It doesn't do writes, so it's in the write-through mode. And we'll see how we can configure this. So, like I said, it's configured per host. It's not a cluster-level setting. So, for today's lab and to show a few things, what I've done is I've created this flash cache just on my first 2 hosts and not on the third one. And we show how the behavior differs when there's one host that doesn't have a flash read cache configured on it. So obviously this is virtual and doesn't have a real flash, real SSD. So what I've done is I've tagged a spinning disk as a SSD, and you can look up William Lamb's article on it, and how you can assign a tag to a spinning disk, and it behaves as a SSD. Obviously you wouldn't get the performance of an SSD, but you can do it for this lab. So what I've done is I've assigned this disk to it, tagged it as an SSD, and once I've done that, I can go into my host here and go manage and then settings. This might also be asked, something like this might be asked in the VCP exam as to where you can configure this. So that's where it is. So manage settings, and here it is. So you go add capacity. So once I've added that new disk here, that new disk will show up here, which is nothing here. So I've already added it, and go cancel that. That's where it's going to show up. If you're removing them, we'll actually do what it says. So it's a 10 gig disk, and out of which it is permitted to use up to 8.9 gig roughly, and the rest of it is used for its own purposes. So the file system that you see is actually a flash optimized VMFS. So it's a highly flash optimized, and it's called the VFFS, or the virtual flash file system. And the device backing here, that shows a disk that actually backs it. You could also add multiple disks here. If I were to add multiple disks here, it'll show up. It'll show up as the second disk here. And you can remove individual disks and put them back into use for maybe proper VMFS. And the flash read cache can actually be used for 2 things. One is for the VMs themselves, and the second one is for the hosts. So it replaces what used to be called the swap to SSD feature, and so they call it the host swap cache now, or the flash host swap cache configuration. So what this allows the hosts to do is, so when there's times of contention and the host needs to swap, it'll swap to SSD and it'll be quicker. But if you're at that stage already, this is probably not that handy. So those are two uses for it. So one is for the host swap cache itself, and then for VMs. How you would assign a flash cache to a flash read cache to a VM is like this. So let's say I've already done this on VM13, so I'm just going to show you how I did it. So I'll edit the settings of the VM. And you can probably see that I've been doing this in the web client. So all of this can only be done in the web client and not in the FAT client or the C# client. How you do this is go into the disk itself. So if there's multiple, so you can also do this by VMDK. So that's also quite handy. So there's only one disk in this case. So what I do is so this thing is going to be 0 by default. So let's say I assign 5 gig out of the 10 that I have available to this VM and go, use 5 gig. So but the moment I put in 5 here, the advanced button here just lights up and it says, enable the flash read cache, which is quite explanatory, and reserves 5 gig, and I can, reserve up to whatever's available. The block size here, so you determine that, by the guest OS and the application that runs inside the guest OS.
Hey Manny, we've got a question.
Go for it.
Okay, so configuring the disk at the BIOS level, are they individual, or can you put the flash disks into a RAID 0 configuration and have the BIOS present the disk as a RAID 0 disk to the hypervisor?
Yep, great question. I would leave them as they are. I wouldn't write them.
Okay, thank you.
No worries. So as for the block size, so that's default is 8 kilobyte. That may be a question too. But how you can determine the block size is probably going to the vSCSI stats and then run that on the VM and see what the block size is. So 5 gig of cache is reserved for this particular VM. And like I said before, so this flash cache is configured on 2 hosts only, just for this demo. And 10 gig is available here too. So I like the C# client more. So what I might do is, and the other thing to remember is that this flash read cache is only active or in use when the VM's powered up. When the VM's down, as it is currently now, the flash read cache is not used. So just to show that, I've actually got a Putty Session open to that host. So we run a few commands on this thing. ESXi CLI storage. I think it's vFlash, and cache, and get, I think it is. Oh, sorry, list. So this is going to be empty. So as you can see, is that the cache is, although it's enabled on the host, but it's not in use by the VM. So there's no cache at all. So the cache is zapped at the moment the VM is powered off, and it's rewarmed when the VM is powered up, to my mind. I may be incorrect there, but we can figure that out. So we just power this on. And what we might do is we'll try to vMotion this to a host that does not have the flash read cache enabled on it. Let's change host. And so that's the host it's on currently. That host has the flash read cache. What this thing is saying is that VMware tools is not yet active because it's just powered up. And the third one, that's a notable one. So you can't, the next is grayed out. Why is it grayed out? Because the flash read cache doesn't exist. So that's exactly what it says. It's not sufficient for the requested operation. So it needs to move that 5 gig cache to this host, which is not available on the host, so it can't do it. Also, the thing to note is, let's say if the third host did have this flash read cache but didn't have enough, he'll still get the same message. So it's actually a good idea to have the flash read cache the same size on all hosts, so your VMs can freely move around as needed. I'll just quickly draw it up on the whiteboard too, how this thing works. So new whiteboard, and hopefully I can do a decent job of this. So that's my host. It's actually a pretty even rectangle. Getting better at this thing, or maybe not. So let's say I've got this VM, there's a few VMs on this, and let's say this is 1, that's 2. So 2 doesn't have the flash read cache, the 1 does. So let's talk about 1 only. So at the bottom here, so not the bottom, but let's assume that you've got 3 SSD disks that are participating in this flash read cache. And you've got your storage array at the bottom here. So what this is going to do is, so let's choose a different color. So at the beginning, the cache is empty, and the cache, like I said, needs to be warmed up before it's actually of any use. So that's your FRC, or the flash read cache. Let's put the V in front of it too. So, like I said, the cache needs to be warmed up. So once when the VM generates an I/O request, so the I/O will go to the host, go on and sees the host sees that there's nothing in the read cache for now, so it just go directly to the array. So that'll be your your first step in this thing, and then it'll write it to the flash read cache. So that's 2. Once it's done that, the write is acknowledged to the VM, and that's number 3. So now that the flash read cache has this has what the VM needs for next time. So the next time when the VM requests the read operation, it's just going to directly go to the flash read cache and then back. So it doesn't need to go to the array over and over again. So that'll actually enhance your read performance, but not your write performance. You may see that the write performance is also enhanced because this is not used by that I/O request again. So your writes may also the write performance may also increase for this. And this the flash read cache is only available for VMs at hardware version 10, I think it is, yeah, hardware version 10. And you can have a maximum number of 8 SSDs per virtual flash file system. There's a 2 terabyte total cache limit, so you can have a total of 2 terabytes of SSD disks that can participate in the flash read cache. And I think someone asked this question in the beginning, and the answer to that is, so when I was doing this here, I was assigning the flash read cache to a VM, you can actually go in and allow up to 400 gig per VMDK. I think that was the first question that was asked. But yeah, that's what the answer is. So there's 400 gig per VMDK limit. The only real use for this flash read cache maybe is for some VDI workloads, especially when VMs start up. That's a mostly read operation, so this might come in handy there. Or maybe in when you have maybe proxy servers which respond to a lot of read IOs, and maybe data warehousing maybe. So that's where this flash read cache can be beneficial. But this has mostly been superseded by vSAN. vSAN is definitely the way to go, and given the enhancement that was announced in VMware 2015, so vSAN is definitely the way to go. Pernix data also do something similar, and they do read and they accelerate your reads and writes, so that may also be one of the things that you may want to look at. I think that's pretty much it from me. Is there any questions, guys? Chris, Imad?
Let's see. So somebody reiterated your comment about Pernix, about about doing read and write.
Mm-hmm.
Can you configure flash read cache to distribute the total cache across all VMs, or leave it up to the hypervisor to manage the cache based on I/O or another performance metric, i.e., high virtual memory swaps?
Now, that's done per VM, so you need to configure this per VM. It doesn't happen across VMs. Now, for something like that, you'd probably Pernix data is a great example.
Right.
So Pernix data exactly lets you do just that. So you can create a flash data store, and you can keep plunking your VMs into that data store, and the time that they are in the data store, everything's going to be fantastic.
Troy responded again. So vSAN, like you say, then.
Yeah, definitely. Yeah, vSAN is the way to go. Yeah, definitely. I think this particular thing, the VFRC, has probably been dropped into the history bin already. Yeah, vSAN is definitely the way to go. Definitely.
Yeah. Cool. I think that was it. Graham commented, vSAN is a file system, VFRC is a caching system. I think that's a comment, not a question.
Okay, yeah. They create their own file system, yes.
Troy said, another license I have to buy now, LOL. Isn't vSphere comes with is it Enterprise or vSphere comes with which licensing?
vSAN's
do you need to purchase a different license? Yeah.
Yeah, it's a separate license, and then you also have another license if you use all flash vSAN.
Ah, gotcha. Okay. I think that's it. Imad, do you see any other ones?
Well, let's see. Graham is talking about their different things. He said, Graham's saying it comes with Enterprise. I haven't seen that, but definitely check that out if vSAN comes with Enterprise. I know you have to have a separate license for it. There is a limitation. I know that.
It's just on a slight tangent. So stuff like this may also be good candidates for the VCP exam. So yeah, make sure that you know your license levels that are needed. This applies to any section of the blueprint, not just this one.
Right.
Yeah, they're pretty fond of the licensing, so you make sure that you know which license allows you what feature.
There's a big back and forth about vSAN. I'm pretty sure vSAN is a standalone product. You have to have a separate license. So
I might just show people the Putty Session again. So like I said before, so the moment the VM is powered on and the cache is warmed up, it'll show up down here. So stuff like this is also maybe maybe on the exam too. So I'm not saying it's going to be on the exam, but maybe on the exam. So that's the cache that is now on this host, and you can see that it appends the name of the VM next to it. And I don't know where that number comes from. That's 361. I don't know where that comes from, but that's what the cache is called. And you can get some pretty handy stats, I think, which go, if I go stats here, and I'll tell you, get, okay, -C, and I think I need to plug the name of this in here. Yep, sure enough. So it lets you see how much I/O it's cached and the latency and everything else. So obviously the latency is not that high, even though it's a static, a virtual nested disk. So that's where you can see the various stats. That's it from me.
Okay. I'm just curious, have you taken the VCP6 yet?
Yes, I have. But not the full one, but only the Delta Beta.
Oh.
Yeah, that's what I took too.
Yeah, I know everyone's eagerly waiting for them. Sorry, what was that?
Well, what I was going to ask, I'm sure people are wanting to know, as far as any kind of tips, tricks, what did you use to study, things like that could help them out?
Yeah, definitely. So like I was saying before, these three URLs are pretty handy. There's also a few practice questions that people have on their website. So I don't have them on my blog, but I highly recommend that people go on to techexams.net/forums, and if you go into I'm pretty active on this forum too. And if you go to the virtualization forum, I started this the daily quiz, probably the biggest thread in maybe not the biggest, but one of the biggest ones in the forum. So that's what I started, and a lot of people have contributed. So there's about not 300 questions, about 100 and something questions in there. So that's pretty handy too. And
techexams.net.
Cool. Yeah, I highly recommend people should be on this. Just so people know, this particular website is probably half the reason why I am at where I am in my career. This is just fantastic. Even if not for the technical part, just for motivation. There's some pretty smart cats on this website, so great to be on here. Also for the VCP, lab it up, folks. Lab it up as much as you can. It's never enough, so lab it up. The more you lab, the more you learn. And please don't do it on your production cluster. You don't want to break stuff. Also,
Way better.
I think that someone asked this question about how about a manager having too much permission and clicking around. So you must lock down permissions and don't allow people to put VMs wherever they want to. So that comes back from the resource pi paradox thing. So where even if a VM is meant to have more resources, it actually ends up having far less resources. So just make sure that you've got your permission locked down.
There is a question, how long did it take you to go through the beta exam? Now, I know the beta has more questions than the regular VCP.
Yep, I sat through the whole of it. I didn't go any faster. I think I had 100 questions. Was it 125? I just can't remember now. But personally, if I don't make it, I'll probably just go for the VCIX when they become available.
Yeah, I think that's what I'm going to do. That way you kill two birds with one stone, right?
Exactly.
Yeah,
exactly.
that's something
Totally. Yeah, I think the beta result's going to be out on the 24th or 28th, was it, of this month? 24th, I think.
Maybe I've
Yeah,
heard
Paul's.
I'm not sure.
Yeah, Paul Sorensen put it on a blog somewhere on VMware.com, and 24th or something. Yeah.
So if there's no more questions, I don't see any on Twitter. Any more questions? Okay. What I'm going to do now is we're going to go ahead and stop the recording.